This week on Engineering Newswire, we're making bendable fibers inspired by living muscle and crafting perfect glass.
Nylon fibers can be used to make inexpensive synthetic muscles, turning a common material into a show of strength. A doctoral candidate at MIT leads the development of nylon artificial muscle. Using twisted coils of nylon, previous researchers were able to replicate the way human muscles move, at least in their linear sense. The fibers could be extended and retracted. However, it was difficult to make a version that could bend with the flexibility that matches human ability. Doctoral candidate Syed Mirvakili and mechanical engineer professor Ian Hunter found that heating nylon fiber on only one side could strain it enough to make it bend more fluidly. The heating method works better because nylon has low thermal conductivity. The heat on one side of the fiber doesn't travel to the other side by the time the hotter side bends under the strain. Heating the fiber can also allow the movements more complex than just bending in one direction. If the heat is moved from one side to the other in select patterns, the fibers electively dance, moving in figure eights and circles. The researchers tested a variety of heat sources, including electric resistance heating, chemicals, lasers, and conductive paint. Manufacturing nylon and its heat source this way could be easier than creating some of the exotic materials that have been used to create bendable synthetic muscle before.
This diagram may not look like much at first glance, but it represents a fundamental way in which glass behaves at the molecular level. Researchers at Princeton have been working on creating the perfect glass, which never solidifies. Glass is an odd thing. There has been a lot of debate about whether glass is technically a liquid or a solid. Its molecular structure behaves a lot like a liquid even though it looks like a solid from the outside. As it ages, glass solidifies completely, crystallizing at the molecular level. The team at Princeton found a way to make a glass that never crystallizes, even if it's frozen to absolute zero. Making it behave this way involved performing modeling to show the possible interactions between pairs of particles. By studying 2, 3, and 4 body interactions which did not naturally occur, the researchers could find out how to suppress crystallization. On a practical level, this means that the glass is impervious to outside forces and is also an excellent transmitter for sound. It also offers some more esoteric answers, including a potential solution for the entropy crisis paradox. For more on that, check out Princeton's newsfeed. That's all for this week's Engineering Newswire. For the PD&D channel, we've been your hosts, and we'll see you next week maybe.
Thank you.